Okay, welcome back to AP Statistics. Today our goal is to discuss graphical displays, the idea of taking data out of the big bulky data tables and organizing it and creating graphical displays through which the information can be viewed visually. Let's begin with an overview of the types of different displays we'll be discussing today. Number one, we're looking at a frequency distribution, which is actually not a graph, but a way of organizing the data in order to make the other charts and graphs that we'd like to look at. We'll lump the next two together, pie charts and bar charts. As we look at those, the interesting characteristic of those is that they are used for categorical data as opposed to quantitative or numerical data. We'll move on then to dot plots, stem and leaf plots, histograms, something called ogive charts or cumulative frequency charts, and we'll end up with box plots, but we'll save most of the box plots for another lecture at a later date. So let's begin. Frequency distributions are used to organize and summarize the data for further study. We're taking large volumes of data and breaking them down into just what we need to look at that point in time. They help us make the other graphical displays that we're going to be using, and they sometimes begin to show some basic information about the data itself. Here to show you an example of frequency distributions, I'm going to zoom in here and go to a website. Here I'm seeing students' test scores. I have a math class of 40 students and their respective test scores. This is a bank of data. When I break it into a frequency distribution, I break it into classes or bins. This bin is 41 out of 50, 50 out of 60. The bins all have the same width. However, notice the frequency now is the count, how many people have been put into those bins, fitting into those score ranges. I'm going to zoom down here and take a look at another way of creating a frequency chart, and this is going to be considered a relative frequency. So I have the original frequency chart here, and then I take the relative frequency where I have 1 out of 40, being that there were 40 students, I get 2.5%. 2 out of 40 would give me 5% at this point. Moving down, I have 14 students that fell in this bin, and that gets me 14 out of 40, or 35%. It should be noted that the percentages should add up to 100%. Another way to work with a frequency distribution is to add the frequencies, that is, taking 1 plus 2 to get 3, 3 plus 6 to get 9, 9 plus 8 to get my 17. I'm accumulating. At the bottom of this chart, I would expect to see 40. So now we're talking about bar charts. Bar charts show frequently and infrequently occurring categories. They are reserved for categorical data, not numerical. The comparisons then are made between the categories in this graph. That's its job. You should note that we want to keep space in between the bars because the categories are not numerical, they're not continuous, they're separate, they're different entities. When thinking about using a pie chart to display data, again, it must be categorical data that we'd be using here. Pie charts do their best at showing proportions. They are typically used with relatively small data sets, particularly if you're building these by hand. However, most of the times we'll be using a computer if we build any at all in AP Statistics. But it is important to recognize that you are definitely looking at categorical data when you're viewing a pie chart. Dot plots are used with small to medium-sized data sets. They do a great job of showing the distribution, that is, the shape of the data set. They also are a very good first look at the data's characteristic, as they're easy to make. They help show the presence of unusual data points or even gaps in the data where points are missing. It should be noted that also that one dot may represent more than one data point when you're dealing with larger data sets. When working with small and medium-sized data sets, sometimes it's useful to use what's called a stem and leaf display. Here, the data is displayed in order. It gives us a good idea of the distribution. That is, again, the shape of the data set. It also displays the actual numbers, which is one of its big benefits. Take, for instance, the stem and leaf display displayed here. What we're seeing is a range of values in the data set of 5 to all the way up to 98. The stem then represents the tens place, and the leaves are represented by the values in the ones place. By recording all these values in the ones place, we see that we have the actual distribution shaping up as something somewhat mound-shaped, with the exception of that 98 being sort of a potential outlier. Probably the most important graph we're going to spend time looking at in this course will be the histogram. It is typically used with large sets of data, in which the data has been placed into classes or bins of a specified width. It's important to recognize when looking at a histogram that the bins all have the same width. If you recall back to our frequency distribution, the table we made, this is perfectly set up for these bin widths for making a histogram. As we saw in our discussion of relative frequency tables, we could also accumulate those values and create now what's called a cumulative relative frequency graph, or an ogive chart. These displays will be discussed in class with an activity, but it's important to know right now that they display the relative position of an individual within the distribution. We're going to finish up our discussion of graphical displays here with box plots. Again, this will be an activity that we'll do in class. Not that these displays have been unfamiliar to you, they're review for the most part, but just a little bit of background and information here to refresh our memories on graphical displays and to go into a little bit more depth as to how we're going to be using them in AP statistics. Stay tuned for the next video and take your notes and be prepared for class.